Alright, welcome back. So we're almost done this one here. So I finally have the equation for my archway. The thing I have to figure out now is if my truck can fit. So if I assume the truck can drive right down the middle, it's his best chance. Where it's going to run into problem is at the edges of the truck here. So if our truck is 5 meters wide, I now have a distance of 5 meters here at the base. So if that 5 meters is centered, again at the middle, because we're assuming it can drive down the middle, that means I have 2.5 meters on either side of the center of the arch. Okay, so if I'm looking for where the edge of the truck happens, it either happens 2.5 meters to the left of 15 or 2.5 meters to the right of 15. Okay, I can use either one I want because really it's a truck, it's going to be the same at both edges. So let's just say I use this one here. So it's going to be 12.5 meters from the edge. Okay, if you want to, you could use this one. This would be 17.5 meters from the edge. But we're going to try and figure out here, because the edge of the truck happens at 12.5 meters, we're going to throw that into the equation of the arch, see how high the arch is, and then compare it to the actual height of the truck. Okay, so let's try that. Let's put in 12.5 for x and see what happens. Okay, really ugly a value here, but again, not too worried about it. It's not going to affect too much. So I get 12.5 minus 15 all squared plus 10.8. So I get negative 2.5 in here all squared. And just simplify it here. So just run this through your calculator, see what happens. And I get, okay, when all is said and done, I wind up with 10.5 meters. Okay, let's think about what that means. Going back here, this says our arch is 10.5 meters tall here. Okay, the truck is 7.5 meters tall. So the arch is taller than the truck, so the truck will fit. Okay, that's really what we were looking for here. Was it safe for the truck to drive down there? And yes, if it drives down the center, there is going to be actually 3 meters of clearance. Truck's 7.5 meters high, archway is 10.5 meters high. Okay, so again, nice little tricky word problem there that, again, just gets us thinking and how we can apply this in different ways. Okay, so for the next little thing here, for this to make sense, you should have done the investigation using Desmos on investigating partially factored form. Okay, so one thing with partially factored form, just do a quick recap here in case you forget what you did in the lab. Okay, so I'm going to look at a couple of equations over here using Desmos. So the first one I have is negative 2 bracket x minus 4 bracket x plus 2 minus 1. So it starts off looking like factored form with your a value out here, your two factors, but this minus 1 here is hanging around. So let's think about what kind of difference that actually makes on the graph. Now, if this minus 1 were not here, okay, this would be factored form, and we would have zeros at negative 2 and positive 4, which we can see right from our factors. But this minus 1 changes things. It shifts everything down 1, so now our zeros are not at positive 4 and negative 2. What it does give us, though, is 2 points that have a y value of negative 1. So when y is negative 1, okay, I have a point there at x equals 4, and again over here at negative 2. So the x values from the factors here are no longer the zeros, but they give you a y value of negative 1. Okay, and you think about this, if I put x equals 4 into this equation, it makes this whole factor 0. So I have negative 2 times 0 times something. All that is 0, so you have to with y equals negative 1. So what this tells you here about the graph is not the x-intercepts, but it tells you that you have a point at 4, negative 1. So again, that's this one over here. And another one at, there it is, negative 2, negative 1. So why is this helpful? I mean, it's not the vertex, it's not the x-intercepts. Why would we bother with this form? Well, the nice thing about it is, even though these x values of negative 2 and 4 are not the x-intercepts, we can still use them to find the axis symmetry because these points have the same y value, they're at the same height. So I can still find an axis symmetry by going 4 plus negative 2 divided by 2. So 4 plus negative 2 is 2. Divided by 2 is 1, so it should tell us we have an axis symmetry at x equals 1. So let's take a look here, and sure enough, there's my axis symmetry. So even though this partial factor form doesn't give you the x-intercepts, it still gives you 2 points that we call symmetric points, because we can use them to find the axis symmetry. Okay, So let's take a look at another example here. So here's 3x bracket x minus 4 plus 11. So again, if that plus 11 wasn't there, you'd think it was factored form. You'd have two x-intercepts, one at 0, one at 4. But putting that plus 11 again back in shifts everything up 11. So now I have 2 points where y is equal to 11. One at 0, okay, and the other one at 4. Okay, so again, why is this helpful? Well, because these 2 points have the same y value, I can use them to find the axis symmetry. So halfway between 0 and 4, you get 2. So x equals 2 should be my axis here. And it is. Okay, so this is called partially factored form. So it kind of looks like factored form, but it's only partial factored, which is why we have this extra term hanging around here. And all it does is it gives you the y values of the x values you get from the factors. Okay, so let's go back to the lesson. So if I'm looking for 2 points equidistant from the axis of symmetry, what I'm looking for here is, again, 2 points I could use to find the axis of symmetry. So your first thought might be, hey, let's find the zeros. The zeros are equidistant, they certainly are. However, 2x squared plus 8x plus 5, you can try that all day, you will not be able to factor it. So unfortunately that way won't work. What we have to do instead is partial factoring. So we're actually going to try and take this equation and put it into partially factored form. And the absolute easiest way to put things into partially factored form, I'm going to start by writing out the equation here. 2x squared plus 8x plus 5. Okay, so I'm going to completely ignore the constant, the 5 here, and I'm going to look at the 2x squared and the 8x, and I'm going to common factor them. Okay, there's always going to be at least something you can take out, because at the very least they both have an x in them. If there's more you can take out, that's even a bigger bonus. But between 2x squared and 8x, here I can take out a common factor of 2x. Okay, what's left over from just these two terms? If I take 2x out of here, I get x. If I take 2x out of 8x, I get plus 4. So I have 2x times bracket x plus 4 with my plus 5 still hanging around. And in that one step, I am now in partial factored form. So what this tells me is not the zeros, but it tells me that I have a point that when x equals 0, y is equal to 5. Okay? When x is negative 4, again, y is equal to 5. So why are these points special? I can now use them to find the axis of symmetry. So 2 points equidistant from the axis of symmetry will be 0, 5, and negative 4, 5. Okay, with that in mind, I actually have everything I need to actually find the equation in vertex form. Because I have my axis of symmetry, I can use an equation to find the y value of the vertex, and I'm off to the races. So using these 2 points that I just found by using partial factoring here, my axis of symmetry is going to be x equals 0 plus negative 4 all over 2. So that's going to give me negative 2. So that's my axis. Okay, and just like a few units ago, if I want to find the y value, I just sub it in to the I sub in the x value of the vertex, the axis of symmetry, into either form I want. Again, I can use this partial factor form I came up with, or I can use standard form. It doesn't matter. It's really whatever you're more comfortable working with. I'm going to work the partial factored form. So I'm going to have y equals 2, replacing x with negative 2. And here I'm going to have negative 2 plus 4, again with the plus 5 hanging around. So simplifying here, I have 2 times negative 2. Negative 2 plus 4 is positive 2 plus 5. So that gives me negative 8 plus 5, negative 3. Okay, so now I put those together. I have my vertex. It's at negative 2, negative 3. So I can create vertex form. Okay, start with my general form here. Sorry, that's a squared plus k. Okay, I have h and k. So that's x plus 2 all squared minus 3. Okay, and again, for my a value, remember it's the same a value from standard form. So in standard form, my a value was 2. My a value in vertex form will also be 2. So I'll make that little substitution in here, and then I'll be done. Okay, so this partial factoring can be pretty useful. I mean, normally to put into vertex form, we'd have to actually have the zeros, so we have to be able to put it in factored form. But again, what you saw here is a situation like 2x squared plus 8x plus 5 where it wasn't factorable. So this is now another way we have to be able to put it into vertex form even though it's not factorable. Okay, it's not, and once you do a few of these, putting something in partially factored form doesn't take tons of time, just a matter of common factoring the first two terms. Okay, so it's really not too bad at all. Okay, so I'll give you one more example here just to practice working with partial factored form and moving to vertex form. So I want the equation of the quadratic in vertex form in the end that this equation has the y-intercept of -4 and passes through the points 1, 3, and 4, 3. And it's these points we have to use to create the equation. Because normally, if I given you the vertex, you could create vertex form. If given you the zeros, you could create factored form. And given you none of those, but I have given you 2 points that you'll notice have the exact same y value of 3. Okay, so I can try and create partially factored form based on that. So I'm going to have y equals some a value. Okay, I can't forget that a value. So my x values of these points are 1 and 4. So I get what appears to be factors of x minus 1, x minus 4. But the y value is 3. So because this is going to be partially factored form, I have plus 3 hanging around here at the end. So that's my basic equation in partial factored form. I just need to find the a value, and then I can do whatever I did before. So to find the a value, just like with every other form we've worked with, I need to sub in a point. So the point that I have here is the y-intercept of -4. So I'm going to sub in the point 0, -4. Okay, and that will help me solve for a. Okay, so it'll take some algebra here. So I have -4. I'm going to have a times -1 times -4 plus 3. -1 times -4 is positive 4. Okay, solving for a, subtract 3 from both sides, I get -7 on the left side. So a is -7 over 4. Okay, a lot of work there, but I finally have my equation in partial factored form. So I get x minus 1, x minus 4, and then plus 3. Okay, so this is all well and good. It's a good start. We just need to be able to find our vertex. We'll put this in vertex form. So I'm going to have you guys try this on your own. Try and find the vertex of this guy, and then see if we can build the equation in vertex form. Okay, so pause it for now. Give it a try on your own, and push play when you're ready to see the answer. Okay, so if you want to see what I've got so far, I started by using the x values here. So both these x values have a y value of 3, 1, and 4, so I can use them to find the axis symmetry. 1 plus 4 over 2 gives me 5 halves. And to find the y value of the vertex, I substituted into the equation for x to solve for y. Okay, there's a lot of work with fractions here. Once you work through it, you should get 111 over 16 as the y value of vertex. So you have your vertex at 5 halves for x and 111 over 16 for y. Okay, so now it gives us most of our vertex form, but we're looking for the a value. Now, a couple ways of going about the a value. We can do what we did before. We can sub in a point that we haven't used yet in creating vertex form. So we could use the point, again, 1, 3. We could sub in the point 4, 3. We could sub in the point for the y-intercept 0, 4 and solve for a. No problem with that. Or we could remember that the a value is the same as in standard form. Now, unfortunately, we don't have standard form here. You can see it here in the answer revealed, but how do we actually get that? So if a really quick way to see your a value in standard form without having to go through all of the entire expansion is just to quickly look at your a value right here, okay, and multiply it by all the coefficients of x here. So here I have -7 over 4 times 1x times 1x. So my coefficient standard form, if I were to put it through an array, will be -7 over 4 times 1 times 1, which is -7 over 4. So in standard form, I know without doing tons of work, I'm going to have -7 over 4x squared plus something else. Okay, I don't really care what that something else is. All I cared about was my a value in standard form. Once I see that's -7 over 4, I know I can carry over that y value, that a value into vertex form. Okay, so that gives me y equals -7 over 4 bracket x minus 5 over 2 squared plus 111 over 16. Okay, so that's it, that's all. A lot of work to get there. There's some more practice here. Just make sure you do it if it's good practice, and we'll move forward with some more in the future. Okay, cheers.